Welcome to the debate. The topic today gets right into a really fundamental architectural choice we all face in C++, doesn't it? It's that decision between making an operation a member function, the classic Object.Dot do something, or designing it as a non-member, non-friend free function, like do something object.
Exactly. And it sounds simple, maybe just syntax, but it's much deeper. It really forces us to think about that underlying tension, that pull between classic object-oriented programming, where the object is king and holds all its behavior, and, well, the more modern C++ approach, the generic programming style we see in the STL ethos, as you called it.
Right. And that brings us to the central question for today. Which way should we lean? Which design philosophy? This older object-centric view favoring members, or the modern algorithm-focused preference for free functions? Which one actually helps us build software that's more robust, more flexible, easier to maintain in the long run? I'll be arguing that actually a strong preference for non-member, non-friend functions leads to better architecture, primarily through maximizing decoupling.
Okay. And while I definitely see the appeal, the, let's say, architectural purity of that argument, I'm going to be making the case for why member functions are often indispensable. I'll argue they're critical for conceptual cohesion, for basic developer usability. Discoverability is huge, and frankly, for efficiently managing an object's internal state. We can't just chase purity if it makes development harder.
Well, my core stance really starts with rethinking what we mean by encapsulation. It shouldn't just be, hiding data in a narrow sense. Architecturally, I think we need to define it more pragmatically. Think of it as minimizing the blast radius of change.
The blast radius of change. I like that. It's evocative.
It is, right? Because every single time we add another member function to a class, we're actually increasing the amount of code that's tightly coupled to that class's private implementation details. It sounds counterintuitive maybe, but a class with n+1 members is demonstrably, I'd argue, less encapsulated, more brittle than the same class with just n members. So this leads to what some call the principle of the minimal interface. Basically, if you can implement some functionality using only the class's public interface, you should implement it as a free function.
Okay, I follow the logic, the architectural purity argument. But how does this minimal interface idea actually hold up when it, meets a large development team that just wants things to be easy and obvious? How does it survive first contact?
I think it survives precisely because it builds in resilience. When you make that utility function a free function, it acts like a strong firewall. It doesn't get unnecessary privileged access to the class internals. And the benefits are clear. You maximize decoupling. You encourage a more granular physical design, smaller headers, optional dependencies, and you help the class itself stick to the single responsibility principle. It just focuses on managing its core state and its invariants. That's it.
That's an interesting framing. But, I tend to frame the core tension more around the developer experience side of things. Look, maximizing decoupling is a worthy goal, no doubt. But member functions are just essential, I think, for creating APIs that feel intuitive, that hang together conceptually. The whole point of the object-oriented model, or a big part of it, is that it effectively groups state and the behavior that acts on that state. It gives us that simple mental model where operations that feel like they intrinsically belong to an object, like, asking a vector for its capacity, it just feels right for those to be members.
But relying on what feels right, or a mental model, that seems a bit subjective when we're trying to establish solid architectural principles, doesn't it?
It might be subjective, but it has really profound, pragmatic consequences. And maybe the biggest one is simply discoverability. Let's be honest, we all do it. You type the object's name, you hit the period key, and you expect the IDE to just tell you what you can do. That auto-completion magic instantly shows all the member functions. It's a form of self-documentation right there in the workflow. Free functions, even if they're nicely organized in namespaces, they force the developer to break flow, to remember headers, maybe do a search. It adds cognitive load.
I absolutely concede the ergonomic convenience of Object.Dot. Nobody denies that's handy.
But my point is that convenience isn't always worth the architectural cost, the cost of reduced encapsulation and tighter coupling.
And there's more to it. Member functions enable a really valuable technique that free functions just can't replicate cleanly. Fluent interfaces. You know, builder patterns, object configuration setups, that ability to chain methods like Object.setOptionA.setOptionB.build, it's incredibly readable, very expressive. Trying to get that same level of readability with free functions usually leads to horrible nested calls which, frankly, become painful very quickly. So in many domains, member functions are practically non-negotiable for good API design.
Okay. Let's maybe move beyond the stylistic debate about fluent interfaces for a second and drill into the core technical point. This trade-off between decoupling and the necessity of accessing private state. I still maintain that maximizing decoupling by using free functions, which, again, only depend on the public contract, gives you priceless resilience. It lets you refactor, even completely replace the class implementation without breaking all the utility code that uses it.
But see, that view seems to just ignore a whole class of functions, the ones whose main job is managing state or ensuring efficiency. I mean, any function that genuinely needs privileged, ideally O of 1, access to hidden private data simply to perform correctly or efficiently has to be a member. This isn't about style anymore. It's about meeting performance contracts or maintaining the class's internal invariance.
All right, give me the classic example then, the definitive case study where that need for efficiency completely dictates it must be a member, overriding the decoupling benefit.
Easy. std.string. Why is s.length or s.size a member function? Well, because it absolutely requires direct, constant time O of 1 access to the internal private size counter that the string object maintains. That O1 guarantee is crucial for performance, and it's also tied into correctly handling implementation details like, say, the small string optimization, SSO. You know, that clever trick where short strings are stored right inside the string object itself to avoid heap allocation.
Okay, what if length were a free function? What would be the consequence?
Well, a free function just couldn't guarantee that O of 1 performance without forcing the std.string class to make its internal size variable public, probably through some kind of getInternalSizeGetter, and forcing implementation details like that out into the public interface. That feels like a much worse violation of encapsulation, ironically, than just making length hub member function in the first place, which requires no change to the public API surface. When a function's core job relates directly to guarding or efficiently querying the object's state, it really has a technical mandate to be a member.
I have to concede the technical necessity in that case, yes. The litmus test for membership really has to involve needing non-public access, either for maintaining invariance or guaranteeing efficiency. And this is crucial, we have to constantly fight the tendency to over-apply that rule. Look at the counterexample, std.toupper. It takes a character, maybe from a string, and returns its uppercase version. It's correctly a free function. Why? Because it needs zero knowledge of the string container state. It doesn't care about size, capacity, SSO, nothing, just the character value. Tying toupper to the std.string class just because you might use it on a character from a string would be illogical. It would needlessly grant privileged access and weaken the string class's encapsulation.
Right, that separation makes sense. State-related functions as members, orthogonal utilities as free functions. Okay, so let's pivot then to that bigger architectural picture you brought up earlier, the whole genericity angle, the STL model, versus the usability points we've been discussing.
Yes, exactly, because the STL design is, I think, the ultimate large-scale proof for the power of preferring free functions. That whole model demonstrates that free function templates are the essential tool for achieving true generic programming. Think about algorithms like std.sort or std.find or std.transform. They are deliberately non-member functions. They operate abstractly on iterators, not on concrete containers. And that's what allows one single std.sort implementation to work on std_vector or std_deque, or even just a plain old C-style array. This fundamental separation, containers provide minimal member functions to manage state, algorithms provide maximum genericity and reuse as free functions. That's the bedrock of C++'s power in terms of code reuse.
The technical elegance of the STL model is, well, undeniable. But you have to admit that radical separation does come with a pretty steep cognitive cost, especially for developers who are new to the library or maybe just using it occasionally. You end up with this fragmented interface. You've got the necessary member functions on the container, sure, but then you have this sort of sea of free functions scattered across different headers, algorithm, numeric, etc. It creates real learning friction. Genericity is fantastic for library writers, yes, but if the end user is constantly pausing thinking, wait, which header was STL.accumulate in again? Which namespace? Then the ergonomic cost is real too.
Okay, but I think modern C++ features have done a lot to mitigate that specific usability complaint. I'm thinking specifically about argument-dependent lookup, ADL.
Yes, ADL. Good point. Maybe let's quickly clarify for listeners why ADL is relevant here.
Sure. So argument-dependent lookup basically means that when the compiler encounters a function call, let's use the classic example, swap of AB, even if the swap function itself isn't technically in the current scope or namespace, the compiler is smart enough to also look inside the namespaces associated with the types of the arguments, A and B. And this is what makes the free function idiom like swap of AB work so smoothly. It often finds the right swap overload in the argument's namespace without you needing to explicitly write, say, my namespace swap, AB. It makes the free function approach much more practical, much less verbose than it might have been otherwise.
Agreed. ADL is absolutely indispensable. It's kind of a necessary patch, really, but it doesn't completely solve the discoverability problem, does it? It doesn't replicate that immediate feedback you get from typing Object.Dot in a modern IDE. And the very fact that we've seen serious proposals discussed by the C++ committee for something like unified call syntax, or UCS, the idea being you could write x dot f of y and have it potentially resolve to a free function f xy. That fact alone tells you there's a persistent, widely felt ergonomic gap. ADL helps, but it doesn't give developers that instant dot completion satisfaction they often crave.
Okay, so this tension clearly persists. And it forces us, I think, towards needing a more definitive, systematic way to decide. Since we both seem to agree that member functions are sometimes technically necessary, we need a principled approach, not just gut feel. Something like the heuristic often attributed to Scott Myers or Herb Sutter. That kind of framework helps because it forces you to reserve member status only when it's technically required, making the free function the default preferred architectural choice.
Yes, I absolutely endorse using a rigorous heuristic like that. It prevents decisions based on just, habit or whim. And it's worth highlighting the specific non-negotiable criteria that force you into using a member function. We've already talked about needing access to non-public state for efficiency or invariant management. What are the others?
Well, first, if the function needs to be virtual, meaning you need dynamic dispatch based on the object's runtime type through a base class pointer or reference, then it must be a member. That's just how virtual functions work in C++.
Right. And second, it has to be one of the operators that the language mandates must be members. That's things like the assignment operator, equals, the subscript operator, square brackets, the function call operator, parentheses, and the member access operator, dot. The language spec simply doesn't allow those to be non-members.
Exactly. And then finally, there's that critical case we should re-emphasize where the non-member implementation isn't just possible but actually mandatory if you want symmetric behavior, specifically when type conversions might be needed on the left-hand argument.
Absolutely crucial point. This comes up all the time with binary operators. Say you have a rational number class. You want rational int to work, but you probably also want int rational to work seamlessly. A member function operator defined inside rational can handle the first case easily, conversion on the right, but it can't handle the second case, where the int is on the left. For that symmetric behavior, the operator must be a non-member function, often a friend or using public accessors.
Or probably the most common example everyone encounters, the stream insertion operator, operator C. It absolutely has to be a non-member function so that the stream object, like stdcode.out, can be the required leftmost operand. You can't make stdcount suddenly have a member function for every type you might want to print.
Okay, so boiling it down, the heuristic says, if you can implement it as a non-member, non-friend function using only the public interface, you should. You only make it a member if you hit one of those hard technical constraints. Virtuality, language mandate for certain operators, essential non-public access, or, conversely, the need for non-member status to handle left-hand type conversions.
Precisely. So to wrap up my side, the ultimate goal, I believe, for modern C++ architecture should be an open, highly reusable, algorithm-centric system. And the way we get there is by being really disciplined. Strictly limit member functions to only those tasks fundamentally tied to state guardianship or language requirements. Implement everything else, utilities, transformations, convenience functions, as non-member, non-friend free functions. This maximizes true encapsulation, the kind that resists change and creates a structurally resilient system. And, as I've said, the STL itself is the massive real-world evidence that this philosophy works and scales incredibly well.
And for my summary, I'd say the most effective API design usually ends up being a pragmatic synthesis. We absolutely have to prioritize the conceptual clarity, the discoverability, the immediate usability that member functions offer for the core responsibilities of an object. They really are the public face of that object. But then we strategically employ free functions for the orthogonal utilities, the generic algorithms, fully respecting the decoupling benefits you've championed. It's not about dogma. It's about making a nuanced technical decision guided by a clear heuristic like we discussed that carefully balances that architectural resilience against the practical needs and ergonomics of the developers who actually have to use the code every day.
It really is true, isn't it? That seemingly small choice between ob.dupe and op-ob acts almost like a proxy for the entire architectural philosophy you're embedding in your codebase.
Absolutely, and considering both sides, those deep technical benefits of decoupling and the very real pragmatic realities of developer workflow, that's what leads to a design that is both mature and robust in the end.